So remember from last session, we proved something called the power rule. Today, we are going to do a simple application of the power rule by solving this question. For f of x equal to x cubed plus x plus 4 over x plus 2, find all x values where the graph of f has a horizontal or vertical tangent line. So before we start doing this question, we need to know when exactly our function has a horizontal or vertical tangent line. So if we perceive the derivative of our function as the slope of the curve, then basically when we have a horizontal tangent line, that means the derivative is equal to 0, because that's when the curve is basically flat, right? And when we have a vertical tangent line, it's the exact opposite. It's when our curve is exactly vertical. That means our derivative needs to be d and e. So that means that our derivative does not exist. Why? Because the limit approaches infinity, right? So in other words, when we have a vertical tangent line, that means our derivative needs to equal to something like this, okay? Let's say x over 0, because this expression basically makes the derivative do not exist, okay? So now we can start doing this question. First of all, let's take the derivative of the function. Now let's implement the power rule, which we just proved. So this is x times 3 times x squared plus 1 plus... Now, for this term, we can perceive this as 4 times x to the negative 1 power. And then we can implement the power rule, which gives us negative 4 over x squared. Okay, because negative 1 minus negative 1, negative 1 minus 1 is negative 2. And so we put the x squared on the denominator. Okay, so finally we have a constant term 2, which gives us 0. Okay, after differentiating. Now we can simplify this a bit. Okay, let's make the denominator x squared. So we have here 3x to the 4th power plus x squared minus 4. Okay. So now because we have a x to the 4th power in our function, it makes things a little bit complicated for us. So what we can do is let y equal to x squared. Okay, this is gonna make our lives much easier. So after this, we can rewrite our function as y 3y squared plus y minus 4 over x squared. And now factorizing the numerator, okay, we get 3y plus 4 over y minus 1 over x squared. Okay, now we can start grouping them for when we have a horizontal tangent line or a vertical tangent line. So first, let's find all the x values where we have a horizontal tangent line. Okay. Now, when do we have a horizontal tangent line? Remember, it's when our derivative equal to 0, which means f prime of x equal to 3y plus 4 times y minus 1 over x squared needs to equal to 0. And so we get y equal to negative 4 over 3 and 1. So now, for this y value, let's really think closely about this y value. Is this possible? Now, I can tell you that this is impossible because look here, y is equal to x squared. X squared has to be a positive value, so y cannot be negative. So we discard this value. This is impossible. So this leaves us to one single value, which is y equals 1. Okay, so if y equals 1, then what's x? Now, because y equals x squared, x can be plus or minus 1. Okay, So this is when we have a horizontal tangent line. And second, when do we have a vertical tangent line? Vertical tangent line, that's when our derivative does not exist. And when do our derivatives does not exist? As I just listed here, we can simply make the denominator equal to 0. Okay, so again, f prime of x equal to 3y plus 4 times y minus 1 over x squared needs to be equal to dne, which signifies do not exist. So when does this equation stand? Very simply, it's when x equal to 0. Okay, so this is a solution when they have a vertical tangent line. So therefore, we have found the three solutions where f has a horizontal or a vertical tangent line.